Now, the concept of image compression is also important to all of us, because I mean, it was important sometime before. Now today it's not important because the memory devices have improved a lot. Today memory is very cheap, and memory is available large quantities. But still, I mean, when you want to transmit that information of this size, for example, through a channel whose bandwidth is very small, and then the time taken or number of bits that are to be transmitted is very large. Maybe today the limitation is in terms of the bandwidth, okay, the channel that is available to us. For example, if somebody wanted to transmit an information which is uncompressed, okay, and a compressed version, right? There are standards to compress this. JPEG is one of the standard to compress an image. So when you compress this image like this, I mean, you do see any difference between these two? It's more or less the same. So there is an object here, or there is a, I mean, every information of this is present in this. There's nothing that exclusively missing kind of an information in the compressed version of here. But what you see is the size of the image from 2.1 MB. You have reduced to 15%. You have saved 85% of the information which was here. It's not there in this. Only 15% of the original information is available here. Now, even with 15%, now for example, you are able to see the entire information that is present in the image. And if you are transmitting this through again a channel, then for example, transmitting 2.1 MB takes, for example, 2 seconds, and 308 MB, 0.38 MB, same speed, same channel bandwidth, and 0.30, okay, 0.30 will take, you remember this is 0.3 seconds, right? So 0.3 seconds. So meaning the information rate is, I mean, the time taken for this information to reach the destination is also small, and then the amount of bits that are transferred is also very small. So you essentially have, when you have a compressed version of this, for example, can you go down to 5%? Now, if you go down to this 5%, the image may not be seen. For example, dog may not look like a dog, so you may lose a lot of information. But there is a kind of trade-off between these rate of compression that you want to have. If you have more compression, rate is more and more. For example, I mean, more and more is on this side, like lower side, higher rate of compression. Less and less the quality will be. So it's basically kind of a decreasing, non-linear function of all this. So meaning this is the quality, right? Quality of the image will go down. Okay, this is a high quality, this is a high rate of compression. High rate of compression is you're saving 85%, you are saving 95% of the information. So 95%, 0% is very good. For example, if you don't compress anything, the quality is very good. If you are compressing too much, then there is poor quality. So you essentially have to balance all this with respect to the amount of information that you wanted to spend, right? So amount of information that amount of bits that you can able to sustain with, for example. So you should, if you want to have a good quality, for example, you fix the quality and you decide what is the compression that I want, so that you choose some optimal trade-off between these curves. So you essentially get into a good